Okay, I hope I'm audible to all the students who are attending this lecture. In the last lecture of statistical inference, we were discussing about the errors made in hypothesis testing, and that lecture in the end became a bit incomplete. So I am trying to make it complete for all the students for better understanding. Okay. So what we were doing in the last lecture towards the end, we were discussing about the errors in hypothesis testing. We had talked about hypothesis testing, the basics of it with all the components in the previous lecture. But in the previous lecture towards the end, because of some network error, the lecture in the end became a bit incomplete. So I'm trying to pick up from the same topic in this lecture, which completes it up properly. So now, in the last lecture, we were discussing that there are two types of errors which we make in hypothesis testing. One is called the type 1 error, which consists of rejecting the null hypothesis when it is actually true. Consists of rejecting the null hypothesis when it's actually true. That means it should be accepted, but we are rejecting it. And then we have the type 2 error. Then we have the type 2 error, which consists of accepting the null hypothesis when it is actually false. That means in case of a type 2 error, we are accepting the null hypothesis when it should be rejected. And in case of type 1 error, we are rejecting the null hypothesis when it should be actually accepted. Then in the previous lecture, I had also defined alpha, which is the probability of making a type 1 error, and beta, which is the probability of making a type 2 error. All students can recall alpha is also called the level of significance of a test. Alpha is called the level of significance of the test. Okay, because alpha will consist of that region. Alpha will consist of that region in which we will be rejecting the null hypothesis when it's actually true. Okay, so and then we have 1 minus beta, which is called the power of a test. So guys, in the previous lecture, I had said something that if you reject the null hypothesis, you will conclude that your result is significant. And if you accept your null hypothesis in the end, you will conclude that your result is insignificant. Okay, so let's understand this using the diagram. So I had drawn the diagram in the previous lecture. I intend to draw it again in this lecture, which makes it more clear. Okay, so you can see I'm drawing two frequency curves. This is one curve, normally distributed. Again, it's not looking like normally distributed. Let me make a better picture. So somewhat like this, and you can see another curve which I am drawing like this. Okay, so you can see the two curves. You can see these two curves. One is centered at mu equal to mu0, because the example which we had taken in the previous lecture, we set up the hypothesis for the population mean mu. So guys, my null hypothesis is mu equal to mu0, and my alternate hypothesis is mu equal to mu1. Mu denotes the population mean. Mu0 and mu1 are constants, they are particular values. Okay, so this is my H0 curve and this is my HA curve, alternate hypothesis curve, which is centered at mu equal to mu1. So far it's clear to all the students. Now, if you look at the H0 curve, from the interval estimation lectures, you should be knowing now that what is our acceptance region. So suppose if you look at the critical value for the H0, the critical value will lie somewhere here. Okay, so I can say that this portion is alpha by 2. This portion is alpha by 2. It's a two-tailed test. It's a two-tailed test we are doing. That means it has tails on both the sides. It has rejection regions on both the sides. Okay, so this is alpha by 2. This is also alpha by 2. Both these areas are exactly equal. And alpha by 2 and alpha by 2 sum up to alpha. And guys, this is my acceptance region. This is my acceptance region. If the value of the test statistic falls in this region, I will accept the null hypothesis, saying that my result is not significant. But if the value of test statistic falls in this region, dark region, or in this dark region, I will say that I will be rejecting my null hypothesis, saying that the result is significant. If you reject the null hypothesis, result is significant. If you accept the null hypothesis, result is insignificant or not significant. So guys, you can clearly see alpha is the probability of conducting a type 1 error, because in both the cases you are rejecting the null hypothesis when it's lying under the H0 curve. You can see this area is also lying under the H0 curve and this dark area is also lying under the H0 curve. So you are rejecting it when it should be accepted. And now guys, what will beta be? Beta is the probability of type 2 error. Now what was type 2 error? It was the probability of accepting the null hypothesis when it should be rejected. So I can show it on the screen. The red region is beta. Look at the red region. So this is nothing but beta. Why? Because this area is lying under H0, acceptance region. That means if you see the red area is lying within the acceptance region for H0, but it is lying under the HA curve. That means this portion is beta, which is the probability of conducting a type 2 error. That means accepting the null hypothesis H0 when it should be rejected. You can see the red colored area is lying within the H0 curve but under the HA curve. That means you are accepting H0 when ideally it should be rejected. So you can see this in my lecture notes as well. The dark colored region is the type 1 error, alpha, and the red colored region denotes beta, which is the probability of conducting a type 2 error. So I hope all students have understood diagrammatically. You should be able to understand type 1 error, type 2 error using the statements also, and you should also be able to understand them diagrammatically. Okay, so you should be familiar with the types of tests. I'm quickly doing them for you. One is called the two-tailed test. So guys, in the two-tailed test, my null hypothesis is population mean equal to a particular value. Alternate hypothesis is mu not equal to mu0. Okay, this is my two-tailed test, because two-tailed test allows for both the possibilities, to the left of mu0 and to the right of mu0. So if you look at the diagram, so guys, suppose this is my normal distribution curve. Okay, It is centered at mu equal to mu 0. And guys, suppose this is my rejection region. I have two rejection regions because it's a two-tailed test. This is also alpha by 2. This is also alpha by 2, where alpha is the level of significance of the test. Now guys, suppose this value is mu 0 plus some h, arbitrary h. So this value by symmetry will be mu 0 minus h. So guys, what can I say? In this particular case, my acceptance region is closed interval mu 0 minus h to mu 0 plus h. That means guys, this is my acceptance region. The red region is my acceptance region. What will the rejection region be? Take the complement of the above. You know how to take complement of a set or complement of an interval. If I take the complement, it's minus infinity to mu naught minus h union mu naught plus h to infinity. That means guys, this dark region and this another dark region. Both the dark regions are rejection regions. If the test statistic value falls in these dark regions, you will reject the null hypothesis saying that your result is significant. But if your test statistic value falls in the red shaded region, you will accept the null hypothesis saying that your result is insignificant. So I hope this much is correct. Okay. Now let's look at, this was two-tailed test. Now let's do one-tailed test. Now guys, one-tailed test can further be categorized into two parts. We can categorize the one-tailed test further into two parts. One is called the left-tailed test and one is called the right-tailed test. So left-tailed and right-tailed. Okay, so let's quickly look at it. In left-tailed test, my null hypothesis is mu equal to mu 0. But guys, my alternate hypothesis will become mu less than mu 0. Or if I put it in general, it's going to be like this. My null hypothesis is mu greater than or equal to 0. But my alternate hypothesis is mu less than mu 0. Actually, both are correct. You can take your null hypothesis as mu equal to mu 0 or mu greater than or equal to mu 0. Both are correct. But in my left tail test, my alternate hypothesis will be this, mu less than mu 0. Okay, so if you look at it in pictures, it is going to somewhat look like this. So again, normal distribution centered at mu equal to mu 0. But now since it's only a left tail test, your whole rejection region will be to the left of mu 0. That means now guys, this whole thing is alpha. This whole thing is alpha now. In two-tailed test, recall in two-tailed test, alpha was split into two parts, alpha by 2 on the left, alpha by 2 on the right. But in left-tailed test, you have alpha only to the left of the distribution. Okay, so suppose this is my value mu 0 minus h. So if I talk about my acceptance region, now this whole is my acceptance region. In this region, I will be accepting my null hypothesis, whereas the darker region is rejection region. So I can write, if I write it in terms of intervals, acceptance region is mu naught minus h to infinity. The rejection region will be minus infinity to mu naught minus h. Okay, and the same thing goes for right tail. In right tail test, my alternate hypothesis will be mu greater than mu 0. That means, guys, my null hypothesis will be mu less than equal to mu 0. If I quickly draw a diagram, in this case, my rejection region will lie to the right of mu equal to mu 0. This is mu equal to mu 0. Now, this whole area will be alpha. Okay, and this will be called mu 0 plus h. Suppose h is an arbitrary number, so mu 0 plus h. So again, this whole region, the red shaded region, is acceptance region, and the darker, the black shaded region is my rejection region. And now if I put it in interval form, it's going to look like this. Acceptance region will be minus infinity to mu naught plus h included. Rejection region will be mu naught plus h to infinity. Okay, so I hope all students have understood the concept of type 1 error, type 2 error, how I have shown them diagrammatically. Remember, type 1 error is the probability of, or I can say type 1 error is rejecting the null hypothesis when it should be accepted. Type 2 error is accepting the null hypothesis when ideally it should be rejected. You have seen the diagrams also where I've shown you alpha and beta, where alpha is the probability of type 1 error called the level of significance of a test. Beta is the probability of type 2 error, and 1 minus beta is called the power of the test. And then we have talked about the rejection region, acceptance region for two-tail test, and within one-tail test, further two types, left-tail test, where this is my alternate hypothesis, and right-tail test, where this is my alternate hypothesis. So this is where I stop in this lecture. Okay. I hope all students have enjoyed the lecture. Please note that in the first lecture of statistical inference towards the end, due to some network issue, okay, the lecture couldn't be completed. That is why in this lecture, I started particularly from errors in hypothesis testing, which were already discussed to some extent in the first lecture of statistical inference. So students should watch both the lectures in one go to get a better understanding of the concept, the basic concept of hypothesis testing. Now, in the coming lectures, we'll actually do numericals, which will help us in making a null hypothesis and using the sample data, finding out whether we should accept it or we should reject it. So this is where I stop in this lecture. I hope all students have enjoyed the lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofelconomics@gmail.com. So this is where I stop.